on put call forward parity. And before I get into the put call forward parity, let me just recap a little bit discussion on a very simple forward transaction. That let's say we buy a stock of Apple at $300, and immediately we sell this stock in a forward transaction at, let's say, the price is $303. Now, have we taken any risk over here? The answer is no, because the moment we bought this stock, we immediately sold it in the forward market for 303, and we booked this profit of $3. So this profit of $3 that we made, this is a risk-less profit, and therefore the return that we have earned is equal to the risk-free rate. And that is how this pricing of the forward is done as well. And if you remember, the forward price is equal to the spot price multiplied by 1 plus r to the power t, where this r was the risk-free rate. This is the risk-free rate. So what we can say is that an asset plus a short position in a forward, because we are selling this forward, so this is a short forward. So an asset plus a short forward is basically giving us a risk-free rate, or we can say risk-free bond. Risk-free bond. Now this is the relationship that we have discussed earlier, and we are just revising right now because it is what is being used in this put call forward parity, that an asset plus a short forward is equal to a risk-free bond. And that is what you see in this slide over here, that you have the long asset, the Apple stock we bought for $300, and we sold it in the forward market for 303, right? And the return we made was, so we bought this at 300, we sold it at 303, and we made a return of $3, and that is what the risk-free bond would have also given us. So this relationship, that an asset, and this minus sign over here is there because it is a short forward. So you can either write short, or you can, instead of writing short, you can just write forward with a minus signs, right? Because long positions are shown in positive and short positions are shown in negative. We can rearrange this equation to look like the asset is equal to the forward plus the risk-free bond. And why this is important is because we're going to put it in the put call parity relationship, and let me demonstrate that again. So if you remember, the put call parity was fiduciary call is equal to protective put, and your fiduciary call was a call option plus a zero coupon bond is equal to a protective put, which was your put option plus the asset. Now this asset is what we're going to replace with, since we know that an asset is equal to a forward plus a risk-free bond, right? And where did we get this? We got it from an asset minus a forward, where you buy the asset, you short the forward, is equal to a risk-free bond. And we made the asset the subject of the equation, and we said asset is equal to forward plus risk-free bond. So therefore, since the asset is equal to forward for a risk-free bond, in this protective put, instead of writing the asset, what we can write is that a protective put, or this rather than becomes what is called a synthetic, because it is artificially created. So a synthetic protective put is the put option plus a forward plus a risk-free bond. And this is equal to a fiduciary call, which is your call option plus your zero coupon bond. And this is known as the put call forward parity, where we take the protective put side of it and we convert it into a synthetic protective put, where the put option is there, and instead of the stock we have a forward and a risk-free bond. And this is what is shown on this slide, that the protective put, which has an asset and the put, we substitute the asset part with the forward and the risk-free bond, and this is what gives you a synthetic protective put. And in terms of the equation, what does it look like? So the put option is the same as before, but instead of the stock or the asset, what we have is this forward plus the risk-free bond. And why there is a zero in place of a forward? Because the forward contract has no cost of entering. It requires zero upfront payment. Whenever you get into a forward contract, the value at initiation is zero, and therefore the payment required is also zero. And therefore you see the value that we write over here for the forward is zero, but for the risk-free bond we write the forward price that we have to pay, but not the whole price, but the discounted version, because this price has to be paid at expiration. So we don't need to put all that money aside from now. We only, let's say that price is $100. So we are going to put maybe something like 99 aside, which will grow to 100 at the risk-free rate, right? So we take that $100 and we discount it back to today, and that is how much the risk-free bond will require in terms of investment. And then obviously we have the put option value, which has to be paid, right? So the risk-free bond can be purchased for this discounted amount of the future or the forward price, and the put option premium is given as P0. Now let's check that whether a protective put and a synthetic protective put are the same or not. So this is a normal protective put, which is a put option and the asset, and this is a synthetic version, where instead of the asset we have a forward contract and a risk-free bond. So let's say if the put option expires in the money, which means the spot price is less than, so the Apple stock price falls to 200, whereas we have a put option of selling it at the right to sell it at 300. So what will happen is that you will get your 300 because you have a right to sell it at 300. This ST will be cancelled by ST and you will be left with the X, which is 300. And in the case of synthetic protective put, the F will be cancelled by the F, the ST will be cancelled by the ST, and what you will be left with is 300 as well. Because what will happen is that you will have a put option here as well, which will give you the right to sell the asset at 300. And even though the forward will cause a loss, so you got into the forward contract at 300, but the stock price fell to 200, so you will have a loss of 100 here, right? But this loss of 100 is going to be countered with the gain of 100 from your put option, which will be in a gain of 100 because you have the right to sell at 300 and the asset would have fallen to 200. So this 100 will be offset by that 100, and what you will have is a payoff of 300 from your protective put. So both have X at expiration if ST is less than X, and if ST is greater than X, let's say it goes to $400, the Apple price, then naturally you will sell at $400 and your put will expire out of the money, but you will have the stock and you will sell it at $400. And in this situation, even though your put will expire out of the money, so it will be worth nothing, but your forward will go up in value by 100, because you have the right to buy at 300, rather you have the obligation to buy at 300, and since the asset will be worth 400, so then now your worth will be $400, where F is cancelling F and you're left with ST, which is the same in both scenarios. So now we know that protective put with an asset or a normal protective put is the same thing as the synthetic protective put as well. And therefore, we can say that within the put call parity relationship, where we have a fiduciary call on one side and a protective put on the other side, if we make it a synthetic protective put, then the relationship should still hold. So, on the fiduciary call side, we have our call option and the zero coupon bond. And on the protective put side, instead of having the asset, we have a long forward and a risk free bond. Long forward value is 0. Risk free bond is the discounted value of the forward price, and a long put has the put option premium. And this is what we call the put call forward parity, right? Where it is the put call parity, but within the protective put side, we have replaced the asset with a long forward and a risk free bond. Therefore, because of the long forward, this is called the put call forward parity. And you can have now a double check of the situation that a synthetic protective put is the same thing as a fiduciary call. So let's say the put expires in the money, which is the scenario where the stock price falls to 200, which is less than 300. So what will happen on the protective put side, that your put option is going to be valuable and you will be able to sell the stock at 300 because you have the right to do that. And on the fiduciary call side, your call option will expire out of the money and your risk free bond is going to, the zero coupon bond is going to mature and give you the $300. And in both scenarios, you will have an equal payoff. And if it is, the stock price is going up to 400, which is greater than 300, so the put expires out of the money, the call expires in the money. So in this scenario, obviously your put will be, your long put will be expiring out of the money, but you will still have the stock which you will sell for $400, and or that forward position will give you a profit of $100, and you will have your $300 in your risk-free bond, so you will have your $400. So the F is cancelling the F and you're left with the ST. And in terms of your fiduciary call, your call option will be in profit, so you will have your zero coupon bond giving you the 300 and your call option will be in a profit of 100, and you will be netting a nice $400, which is the exact same amount as the synthetic protective put as well. So you can see that a synthetic protective put is equal to a fiduciary call, and this is what we call the put call forward parity.